Humans don't look up very often anymore. But when we do, it's almost startling how similar the questions we ask are to the ones we asked thousands of years ago. Where are we? How far away is Jupiter? What are stars made of? And is there anyone else out there? The Greeks started it. Well, I'm sure someone thought of it before the Greeks did, but the Greeks were the first to write it down. It began with Leucippus and his student, Democritus, who both founded the atomistic theory together in the 5th century BC. Atomism proposed that the natural world was composed of two things, atoms and the void. Everything is made up of these atoms, small particles which are indivisible, bouncing off of each other inside of the void. For Democritus, atoms came in an infinite amount of different shapes and composition, and if there were an infinite amount of these invisible little things of varying shapes and sizes that we haven't even discovered yet, then there must also be the very same thing on a macroscopic scale. There must be an infinite amount of worlds, of all different structure and size. A good while later, around the 3rd century BC, Epicurus joined in on the conversation. Epicurus was a philosopher who founded Epicureanism. And what did Epicureanism teach? Well, thank you for asking. It taught that the purpose of philosophy, and even more than that, the purpose of life, was to attain tranquility and put pleasure above all else. You can see how this later spiraled into being seen as a hedonistic philosophy. But really, that's a false reading of it. He just believed that people should live a simple life, and pleasure in his sense really just means the absence of pain and fear. So you should go out drinking with your buddies, and you should go on that vacation you want to go on, because that's the purpose of life. Don't purposefully put yourself in pain's way. Anyway, none of that matters. But what does matter is that Epicurus wrote in a letter to Herodotus that we must believe that there are living creatures and plants and other things on other worlds because we can't prove otherwise. Unbeatable argument. One Greek text known as Pseudo-Plutarch expands on a Pythagorean belief. The moon is terraneous, is inhabited as our Earth is, and contains animals of a larger size and plants of a rarer beauty than our globe affords. The animals, in their virtue and energy, are 15 degrees superior to ours, emit nothing excrementitious, and the days are 15 times longer. In fact, the moon was the first planetary mass object which was speculated to have life upon it, way back in ancient Greece. Maybe most notable is Plutarch's text concerning the face which appears in the orb of the moon. Plutarch was a Greco-Roman philosopher and biographer who lived in the 1st century AD. His works were required reading for most students throughout history. If you happen to feel the urge to check him out, I would recommend Parallel Lives, but I digress. Plutarch's text on the moon included a portion in which his characters discussed whether the moon could be inhabitable or not, whether it could sustain life. The characters go on to say that it could not have life on it for various reasons. Number 1, the heat and tenuousness of the atmosphere would not be conducive to plant growth. And 2, because of its orbit and rotation, the moon would throw off any inhabitants it did have, so that they wouldn't remain there for very long. I should mention something before we go any further, and that's that the ponderings and assertions of extraterrestrial life have been spoken of with half seriousness. Extraterrestrial life has always been a joke. In Plutarch's work, his characters speak about the matter with half jesting and half seriousness. We see the same thing today, where those who believe in extraterrestrial life are made the butt of many jokes. And throughout history, it was this sort of tone of voice which scholars and learned men used to put forward assertions or scientific propositions on extraterrestrial life. So just keep in mind that most of the texts that I show you are put forward not with full seriousness, not in the hopes of actually convincing anybody that extraterrestrial life exists, but in pondering if it did exist, how might that work? How might they live? Aristotle was vehemently against the idea of a plurality of worlds, and took pains to disprove it in his work De Caelo, or On the Heavens. In this he argued why there was only one world. Keep in mind that he was a student of Plato who didn't like the theory of plurality very much because it was rooted in Democritus's atomism, which he also didn't like very much because it assumed that the world was very chaotic and random, that worlds appear based on the sporadic movement of atoms. He thought this wasn't true and that the world must have been designed and not this ugly array of randomness. So Aristotle's work on the heavens was what caused quite a stir in the medieval West, where it sort of popped up about a millennium and a half later, and that is the next section of our story. Until about 1170, Aristotle's work on the heavens had only been studied by students in Greece, the Byzantine Empire, the Hebrew and Arab worlds, until it was translated into Latin by Gerard of Cremona and studied rigorously. Whereas in the ancient world, the question of multiple worlds and life on these worlds was more of a philosophical one, in the Middle Ages this turned into a deeply religious question. This brings us to a term that might be helpful to know if you're wondering why medieval Christian scholars are studying ancient texts with so much vivacity. This is because of something known as scholasticism. Scholasticism was a method or philosophical system which sought to reconcile ancient wisdom with Christianity. What that means in simpler terms is, by the 1100s, when this practice became predominant, Western Europe had converted to Christianity, which basically means that all of this work from ancient philosophers who came to conclusions on topics like faith, intellect, reason, will, all of which was often heavily steeped in Hellenism, was considered heretical and wrong. But medieval scholars still liked and respected the works of ancient philosophers, even if they were heretics, and so they wanted to take ideas and conclusions of these ancient thinkers and make them make sense in a Christian context. In one sense, we're having to re-answer philosophical questions which the ancients have already solved because their logic and reasoning doesn't quite make sense in the context of the Christian religion. But on the other hand, we're consulting the work of these Greek and Roman philosophers in order to, in some cases, cherry-pick, in some cases, take the words of these thinkers and twist it a little bit, so that it makes sense when put up alongside Christian dogma.
Anyway, they were doing that for a long time, like 600 years.
But it started, as I say, in the 1100s, and once Aristotle's work made its way to the Latin West, his belief that there were no other worlds was accepted without much controversy. One defender of Aristotle was Thomas Aquinas, an Italian Dominican friar and philosopher and theologian, and a paragon of a scholastic thinker. Aquinas argued that neither opinion held by ancient philosophers on the multiplicity of worlds posed any threat at all to the basic tenets of Christianity or God's existence.
In fact, if there are a plurality of worlds, doesn't that mean that God is omnipotent, like the faith teaches? And even if there aren't a plurality of worlds, like Aristotle says, then that doesn't mean it's not within God's power to make them, right? This is an example of the kind of thinking that these medieval scholastic theologians did.
The question was taken up by William of Ockham, who lived in the 13th to 14th centuries. Ockham was a Franciscan, and he studied at Oxford, and he actually claimed the exact opposite of Aristotle, saying that God was able to create another world and another people, which were better than what we see now.
William never got his master's degree, and he was excommunicated. Not for this. I mean, the master's degree was withheld because of this, but the excommunication was for other things. I'm trying to pull us out of the Middle Ages because their arguments are very theology-heavy and very repetitive. There was not a common consensus, and this is sort of the standstill that we come to, which is God is powerful enough to create these other worlds, but are there other worlds? TBA.
It is in the Renaissance time period, the early modern time period, that we begin to see a genuine resurrection of debate on this topic, with new arguments and methods. Galileo's weighing in, Da Vinci's in on it. We see a mini resurgence on this when both of them start thinking on how another world might make sense more logically, or physically, rather than theologically. Da Vinci begins questioning, why doesn't the moon fall into us? How does the moon stay where it is? People start tossing around ideas again. Maybe the Earth is a star. Maybe there is no center of the universe. Maybe the center of the sun is an Earth. Finally, we see thinkers pondering again on the question of life on other planets, rather than just the planets themselves. Nicholas of Cusa, a German philosopher and cardinal, said in the 15th century that life like we see here on Earth exists in a higher form, among the stars and sun, all with God at their center. Now this is really fun. Cusa speculated and concluded that there were solar beings, which were highly intellectual and existed more in a spiritual state than a physical one. He began to conjecture about life on the moon. He believed that whereas the beings on the sun took a more spiritual form, and people on the Earth were embodied in a physical form, the beings on the moon were somewhere in between. But it's in the 17th century that we really start to see contemplations like this taking off. Atomism is revived. The scientific revolution is in full swing, and this becomes a popular question again, looked at through the eyes of science this time. Pierre Borel was the physician to King Louis XIV of France. We don't know much about him. We do, however, have several treatises that he wrote, mostly on chemistry and physics and philosophy. He hypothesized that were we to look at the Earth from a distance, it would reflect the sun's light back so strongly as to look like a star. Therefore, all of the stars in the galaxy must be other planets. This includes the moon, which he believed must have the same terrain as Earth because Galileo found spots and lines and crags in it that resemble what Borel imagined Earth's terrain might look like at a distance. He stated that on each of these stars there is a multitude of life different from our own, but that we all share the space and air between, almost like a common watering hole. This was explained from a religious perspective by way of God being weary of loneliness and creating not just the Earth and humans, but various different types of life on various different planets. In this way, we see the question of extraterrestrial life being revived again, in light of new ideas and discoveries. John Wilkins, an English philosopher on the natural world, was a big name in science at the time, and he wrote a work called The Discovery of a World in the Moon. At the very start of this work, he addresses his readers and prefaces it by saying that this is more leisure reading. Please don't come at me with heavy scientific discourse. This was not written to be accurate. These are just some lighter, unpolished studies. Even though this treatise is really deeply researched. In it, he expounds on the same ideas that Borel does, that the craters of the moon were lakes and seas, representing the terrestrial qualities of the moon, and he thought there was life up there, but he didn't know how to get to it. This changed when an English priest named Francis Godwin busted onto the scene with one of the earliest science fiction stories about lunar travel. Under the pen name Domingo Gonzalez, in 1638, he wrote something called The Man in the Moon, which is about a Spanish adventurer who noticed some migrating birds and harnessed them to take him to the moon. He finds a sort of utopia, with beings on the moon who are already Christians. This is one of the first times we see any conversation appear on reaching other planets or other life. The conversation up to now has been on whether it existed, but now we have people positing that it does exist, and considering how space travel might work, even if it's in a fictional setting. This story inspires our other English philosopher John Wilkins to revise his original treatise and add a section about the possibility of lunar travel. Both of them thought on this idea, but didn't have a real functional plan for space travel, and essentially chalked it up to a problem for us in modern day to solve. Wilkins wrote that 'tis possible for some of our posterity to find out a conveyance to this other world, and if there be inhabitants there, to have commerce with them. The devices which they imagined to possibly get us to the moon involved building human-powered wings, maybe a chariot, or maybe a mechanical engine. It might come as a surprise to know that famed German astronomer and mathematician Johannes Kepler wrote a painstakingly detailed science fiction work about lunar travel and beings called Somnium. Nearly every sentence in this story has a corresponding note attached to it, over 200 endnotes, in which, as I say, Kepler goes into painstaking detail to explain the scientific accuracy of each claim in the story. The plot revolves around space travel, which takes the form of his characters being transported to the moon by spirits who will apply wet sponges to their face, which will make it easier for them to breathe in space after they are shot from the Earth as if by gunpowder in order to reach the moon. Because of this whole affair, narcotics have to be administered before travel, so that the Voyager is asleep before any of this happens. In Somnium, the moon is called Lavania. On Lavania, there exists two kinds of extraterrestrial life. The subvolvans, who live on the side of the moon which constantly faces the Earth, or vulva, as Kepler calls it, and the prevolvans, on the moon's far hemisphere, which never sees Earth. Generally, the inhabitants have a serpentine nature, because during the day, the light from the sun scorches the moon, and these creatures seem to expose themselves to it, as if for pleasure, before slithering back into a nearby cave when it gets too much. It was during the scientific revolution that the idea of a plurality of worlds became more accepted, more solidified. This was due in large part to the swath of absolute geniuses of the time. Newton's physics served to open the way for this, and it came into general acceptance that there must be other star systems. On August 25, 1835, the first in a series of 6 articles was published under the name of Great Astronomical Discoveries Lately Made by Sir John Herschel. These articles claim that Sir John Herschel, who was a very prominent, very famous astronomer and scientist of the 19th century, had built a telescope lens 24 feet in diameter, dragged it to South Africa, and thereby made discoveries of other planets outside our solar system. He also, the article said, spotted life on the moon, with vegetation, pyramids, bison-shaped creatures, blue single-horned goats, a horned bear, a bipedal beaver that carries its children around in its arms like a human. And finally, actual human-like beings were spotted, around 4 feet tall, with wings, called Vespertilio homo, or man-bats. These articles were all written by Richard Adams Locke, who years later admitted that it was meant to be a satire, and that it wasn't thought that anybody would actually believe any of it. It was thereafter called the Great Moon Hoax, and many people did believe it, and waited every day for each new article to come out about the discoveries, and it made its way across Europe, with the Italians creating lithographs of the creatures listed in the article to go along with the report. There was, however, alongside this, genuine research going on in this century about the moon. In the 1860s to 1870s, various observations were made from several different astronomers which concluded one thing: that the craters in the moon were disappearing or changing. Some astronomers denied it, and others assumed that it could only be possible because of the lunar atmosphere or lunar beings. Later, the idea was put forward that perhaps one might use the lunar canals for Martian studies. Interest within all of these fields began to build, until finally, a prodigy named Charles Crowe, who became a professor at 18 years old, introduced the idea in 1869 of communicating with possible inhabitants of Mars and Venus. Crowe published a work that speculated on the idea of using rays from electric lights focused by parabolic mirrors so that anyone on Mars or Venus might see it. Before he had suggested this, flashing lights coming from Venus had been spotted by other astronomers, and Crowe thought that this might have been the inhabitants trying to contact us. This marked a great leap in Martian studies, as Camille Flammarion, a great French astronomer, wrote that Mars may be home to intelligent races that are far superior to us. Astronomers began reporting more flashing lights coming from Mars. This brings us to a figure you've probably heard of, Nikola Tesla, who was in Colorado Springs with his laboratory and high-voltage equipment when he published a work called Talking with the Planets. Tesla wrote that he had come up with new methods to send electrical signals to Mars with as much exactness and certitude as we now send messages by wire from New York to Philadelphia. Some people, like those writing for the Colorado Springs Gazette, were very excited by this. Others, such as the staff at the St. Louis Mirror, directly said that Nikola Tesla is the Ignatius Donnelly of physics, which is actually very mean-spirited. If you don't know who Ignatius Donnelly was, he was an American congressman who was remembered as a pseudoscientist, a crackpot conspiracy theorist. He wrote a lot of books. In The Great Cryptogram, he theorized that encoded messages could be found in Shakespeare's work and that Francis Bacon actually wrote all these plays. In Atlantis, the antediluvian world, he argued that Atlantis actually existed and all human civilizations could be traced back to it. In Ragnarok, the Age of Fire and Gravel, he posited that loose gravel deposits that had been discovered in northern regions were the result of a comet passing so close to Earth that it spewed gravel over it, and that older civilizations mistook this for Ragnarok, essentially someone that no one took seriously, unfortunately. But maybe the most controversial astronomical discovery took place in 1877 at Brera Observatory in Milan. The highly praised astronomer, Giovanni Schiaparelli, allegedly discovered a system of canali on Mars. This Italian term, which usually means channels, was falsely translated into English as canals. Modern technology tells us that there are in fact no canals on Mars, and the sighting of them by Schiaparelli is attributed to limitations in telescopes at the time, as well as chance alignments of craters and other surfaces on Mars, which caused the illusion of canals. But the observation of what looked like canals in the late 19th century led some astronomers to conclude that there must be life on Mars who created these canals, some highly developed or intelligent beings. Foremost among these was Percival Lowell. A businessman and astronomer, Lowell wrote a paper in 1894 which argued that the canals must have been constructed by intelligent beings. In a book published the very next year, he writes, "We find in the first place that the broad physical conditions of the planet are not antagonistic to some form of life. Secondly, that there is an apparent dearth of water upon the planet's surface, and therefore if beings of sufficient intelligence inhabited it, they would have to resort to irrigation to support life. Thirdly, that there turns out to be a network of markings covering the disk precisely counterparting what a system of irrigation would look like. And lastly, that there is a set of spots placed where we should expect to find the lands thus artificially fertilized, and behaving as such constructed oases should do. All this, of course, may be a set of coincidences, signifying nothing, but probability points the other way. He published 3 books detailing his reasons for believing that there was life to be found on Mars. There were many arguments against his hypothesis, such as the thin atmosphere on Mars, to which he responded, "Lungs are not wedded to logic, as public speeches show, and there is nothing in the world or beyond it to prevent, so far as we know, a being with gills, for example, from being a most superior person. A fish doubtless imagines life out of water to be impossible, and similarly, to argue that life of an order as high as our own, or higher, is impossible because of less air to breathe than that which we are accustomed, is, as Flammarion happily expresses it, to argue not as a philosopher, but as a fish." Such an aquatic spin on the Martian image can be seen to have an influence on popular media at the time, such as the form that H.G. Wells' Martian invaders take in his novel The War of the Worlds. As we enter the 20th century, the development of radio waves was undertaken. Astronomers considered if this, perhaps, was the most effective way to communicate with those on other planets. If radio signals might be sent out, maybe they would reach other planets, and a conversation could be initiated. The first modern attempt at this was undertaken by Frank Drake in Project Ozma, to search for extraterrestrial intelligence, or SETI. This experiment was began in 1960. It was named Ozma after the Queen of Oz, a place which was very far away, difficult to reach, and populated by strange and exotic beings. The gist of the project was that for 6 hours a day, between the months of April and June 1960, a receiver on an 85-foot antenna would be tuned to the frequency of 1,420 megahertz, which it was imagined should be known by any technologically sophisticated society as a universal hailing frequency. The radio telescope was pointed towards the stars Tau Ceti, which is very old, and Epsilon Eridani, which is very young, and both of these stars were assumed to have planets. The entire project only cost $2,000, and after 3 months, the chart recorder showed nothing. Since then, several other SETI projects have been undertaken, though the conclusion remains the same. In July 1969, we even fulfilled the dreams of our forebears and stepped foot on the moon. But there was no one there. As of today, there hasn't been any conclusive evidence that life on other planets exists. That's not to say it doesn't, just that we haven't found it yet. A term called the Fermi paradox appeared during the mid-20th century, which had been articulated before as far back as the 17th century, but was only given a proper name within the last century. It was imagined, as we have seen since ancient Greek times, that there are an infinite amount of worlds, and statistically, the chances should be high that there is life on these other worlds. So where is everybody? This is the Fermi paradox, and this question is exactly the one physicist Enrico Fermi was asking in 1950. It's the one we're still asking today. Truly, we haven't been looking very long. It took us thousands of years just to get to the moon, and though we've put rovers on Mars and slingshotted probes past Jupiter and Saturn, we haven't really made it very far when put into the perspective of the universe at large. The farthest thing we've managed to send is Voyager 1, and he's just a little guy, a tiny space probe about the size of a car. Launched in 1977, Voyager 1 only left our solar system in 2012. Even though it wasn't the original mission of Voyager 1, he's been tasked with carrying the Golden Record, a phonograph recording with sights and sounds and cultures and languages, all from Earth, and all introducing ourselves to anyone who might happen to stumble upon it. The chances of stumbling upon Voyager 1 are so low that they might as well be zero, and we would have no way of knowing if someone ever did find him, as he's not capable of transmitting that kind of information back. In fact, the last photo Voyager ever did send back was on February 14, 1990. He was about to leave our solar system, and NASA scientists commanded the probe to turn back around one last time and take a family photo of all the planets. This was the last thing Voyager saw before he turned his cameras off forever. A pale blue dot caught in a sunbeam, a picture of Earth. In the words of Carl Sagan, that's you. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust suspended in a sunbeam. So, unless anyone goes out looking for him, Voyager continues dutifully on his mission, floating all alone in space. In that sense, he represents us quite well, I think. Humanity has spent a sizable chunk of its existence wondering where we are in all of this. What is out there in the stars? Now we know where we are, on a planet called Earth, in a solar system, inside the Milky Way galaxy, but we still yearn to know what's out there. Moving through such a vast universe all alone is daunting. However, actually encountering other life may sound equally as intimidating. But perhaps that's something we must ask ourselves. Which is more frightening? That there might be someone else out there? Or that we're all alone in the universe?